All right, guys, welcome to Statistics for April 15th. What we're going to talk about today is something called margin of error or standard error. Now, we've been talking about sampling distributions, talking about having some sort of data set where we know this thing called the true proportion, right? So the true proportion is whenever you have this normal distribution and knowing what the mean should be. And I say should, meaning we absolutely know for a fact the universal actual mean. Flipping a coin, we know that is 50%, right? Chance to get heads or tails. Or rolling a dice, we know the chance of getting a 1 on a roll of a die is 1 out of 6. But we don't always know these true proportions. Sometimes, whenever we do studies, we're maybe the first person to ever study this. Or maybe we're doing something that's just not possible to get a true proportion on, an actual factual mean for. That's where standard error comes into play. So let's say we have this situation, right? Let's say we do, we're sampling some for bacteria in this plant. So we go out and we find a whole bunch of this plant all across the United States maybe, and we want to test it to see if it has this bacteria in it or on it or whatever, right? I'm not sciencey, I'm just making up a scenario here. And what we find is that, 40% of the plants that we sampled had this bacteria in them. Now, we can't really say that's the true proportion because maybe we're the first people who have ever tested this. We don't know. It's just simply out of all the stuff that we gathered, we found 40%. So what we do is we have to assume that our average is close to the true proportion. Maybe not exact, but close. So to determine a margin of error, what we do is we use our standard deviation equation that we've talked about the last few days, the square root of PQ over N, to determine what the standard deviation would be if the mean that we found is the actual true proportion of whatever it is we are studying. You guys have probably heard these kind of things before with political surveys or something, right? Like we have a presidential election going on, and if you've watched the news, maybe you hear, that we've conducted a poll and we found that 56% of people feel this way with a margin of error of whatever this is, some number, right? That's where this comes from. Because what they do is in a survey like that, they take whatever they found. If we're asking, do you support this bill, right? And you find out that 65% of people support that bill, well, we don't know the true proportion of support that has. It's not possible to know that. But if we found that 65% of people do, we have to make the assumption that 65% of people across the nation do. That's the true proportion. And we use that in our standard deviation equation to determine the margin of error. So let's do that with this example here, this plant bacteria, whatever it is that I said. We would assume that P, the true proportion, and again, this is an assumed true proportion, would be 0.40 or 40%, right? What we found in our study. Then we would have Q, the opposite of that, 1 minus P, or the proportion that does not fit what we're looking up, which would be 0.60. And then N says however many plants we looked at. Now let's say we got 150 plants from across the nation. So we would put 150 down here. What we need to do is we calculate that, and we say 0.4 times 0.6 over 150, all under that square root. has a 0.04 or 4% standard error or margin of error. So that's what we would say is that 40% of these plants that we're studying have this bacteria with a margin of error of 4%. So this is where you get the news stations or whatever research you may be looking at and you hear about margin of errors, this is where they get that. What I want you to think about is how could we make the margin of error go down? 4% doesn't seem like a big margin of error, but what could we do to make that margin of error smaller? Think about that for a second. Now, what you might be thinking about is it has something to do with this right here, the number of trials that we conduct. Because quite frankly, there's no way to change these really, right? This is just simply what we researched and found. We can't control what we find in our research. And this is the opposite of that, the fail rate of that, quote unquote. But this number we can control, the number of trials. So think about it. Is it going to increase or decrease our margin of error if we conduct more trials? What would happen if we conduct less trials? Well, let's find out exactly. If we did this research again, this one with the plants, and we still found 0.4, I'm going to assume that that's still what we found. But instead of doing 150, we did 500. Think about whether it would go up and down. What do you think? All right. We find now our margin of error, our standard error, is only 0.2 or 2%, significantly smaller. So the more trials we do, the more accurate we can say our data is. That makes sense, right? I think that's pretty logical. But what we can determine, or again, this process is determining our margin of error or our standard error. How far off is it possible that our data is? All right, tomorrow we're going to do a couple of problems as it relates to margin of error. We're going to find some margin of errors. We're probably going to do I'll see if I can find a real life example, with a poll or maybe some coronavirus stuff, or I don't even know what. I'll see what I can find. But tomorrow we'll probably do a more hands-on example where we actually see some data. And yeah, we'll keep this going. If you have any questions, email me, let me know. Otherwise, see you guys tomorrow.